In this video, we'll talk about using L'Hopital's rule and other techniques to take limits when they fall into the form plus infinity minus plus infinity, or minus infinity minus a negative infinity. The thing is, now, in other indeterminate forms, we didn't really care whether something was going to positive infinity or negative infinity. But in these limits, we do. We'll see that in just a second. Now, as in any form, we have to get the thing, if we're going to use L'Hopital's rule, it has to be approaching either 0 over 0 or infinity over infinity. That's all that L'Hopital's rule applies to. So, let me see if I can find my mouse here. So we just want to be careful. Now let's take a look. If we look at this, we have a positive infinity minus a positive infinity. Notice we have a big positive number and we're subtracting a big positive number. It's hard to tell what's going to happen there. So this is an indeterminate form, okay? If we have a positive infinity minus a negative infinity, well, that would be the same thing as a positive infinity plus a positive infinity. So we have one number that's getting big and we're adding to it another number that's getting big. That's going to be a positive infinity. It's not an indeterminate form. If we have a negative infinity and we're subtracting a positive infinity, that would be like taking a negative infinity, a number that's becoming large in the negative direction, and subtracting a number that's large. I guess I didn't really need to write it. If we take a negative number and subtract a large positive number, well, we're going to get a large negative number. So this is not an indeterminate form. Okay, we have to be a little bit careful. Then if we take a large negative number and subtract a large negative number, again, we don't know what's going to happen. All right, so that is going to be an indeterminate form. So basically what you might think of a rule of thumb is that if the signs agree when we're subtracting, then it's an indeterminate form. If they are opposite when we're subtracting, then it's not an indeterminate form. So let's take a look at an example or two, a couple techniques. All right, let's look at this situation. The limit as x approaches positive infinity of the square root of x squared plus 6 minus x. Okay, so let's see, as x goes to infinity, x squared, of course, plus 6 is going to go to infinity, so its square root will go to infinity also. All right, and of course, x is going to infinity, so this is going to be a positive infinity minus a positive infinity, and that's an indeterminate form. Signs match. Okay, how do we deal with this? Well, one way we can deal with this is we can multiply by the conjugate over itself. I'll multiply by the square root of x squared plus 6 plus x. Remember, conjugate will change the sign in the center over the square root of x squared plus 6 plus x. When I do this, of course, what's going to happen here is I'll get the limit as x approaches positive infinity. And when I multiply these conjugates together in the numerator, I just get the square of the first, which is going to be x squared plus 6 minus, because squaring will just take away the radical, I'll get rid of the radical, minus the square of x, which is x squared. And this will be all over, excuse me, the square root of x squared plus 6 plus x. Okay, all right, well, of course, the x squared subtract off, and I'm just left with 6 in the numerator. If I look at this, all right, without too much ado here, if I look at this, All right, I have 6, and the denominator is getting to be a very big number. This is going to positive infinity, plus another positive infinity. So the denominator is getting huge. As the denominator of a fraction gets large, the size of the fraction gets small, so this is going to 0. So this limit would be 0. Notice we use the conjugate, all right, to go from, well, actually, we never use L'Hopital's rule, but to deal with this situation, to get rid of a radical in that situation. Let's take a look at another example. All right. All right, the limit as x approaches 1 from the right of x over x minus 1. Well, notice that as we approach 1 from the right, all right, in this first case, the numerator is positive, and it's going to 1. The denominator is going to 0, but the denominator is positive, so this is going to go, because x is bigger than 1, it's to the right, so this is going to positive infinity. All right, and we're subtracting the 1 over the natural log of x. Well, here's a graph of the natural log of x. And notice at 1, the natural log of x is 0, so we have a 1 over 0 sort of situations. It's going to either plus or minus infinity. But since we're going to 0 from the right, all right, the natural log is positive, all right, to the right of 1. So this is going to be a positive number again over a positive number. So this will be a positive infinity minus a positive infinity. And that's an indeterminate form. Okay, well, how do we deal with this? Well, one way that we could deal with it, I didn't know if I had one here. One way we can deal with this is as follows. We can get a common denominator. I can multiply the first expression by the natural log of x over the natural log of x, and the second term by x minus 1 over x minus 1. If I do that, I'll have the limit as x approaches 1 from the right of x natural log of x, okay, minus, all right, I'll have, when I multiply this by x minus 1, minus the quantity x minus 1 all over x minus 1 times the natural log of x, okay? And so now if I look at this as x approaches 1 from the right, let's see what's happening here. Well, x is approaching 1, natural log is approaching 0, and x minus 1 is approaching 0. So we have 0, 0 on the numerator is approaching 0. The denominator, x minus 1 is approaching, in the denominator, x minus 1 is approaching 0. The natural log of x is approaching 0. So we have 0 over 0 indeterminate form. We can use L'Hopital's rule. All right, so let's see. So what will happen here, we'll have the limit as x approaches 1 from the right up. Well, I have to use the product rule to take the derivative of this, and so I'll get the derivative of x is 1 times the natural log of x, all right, plus x times the derivative of the natural log of x, 1 over x. And then in back here, I'll have minus the derivative of x is 1, the derivative of negative 1 is 0, so I'll just have 1. Okay? So let's see, then in the denominator, what will I have? Well, I have the derivative of the first, which is 1 times the natural log of x, using the product rule again. And then I'll have plus x minus 1 times the derivative of the natural log of x, which is 1 over x. Let's simplify this a little bit. Notice we have the natural log of x in the numerator, plus 1, x times 1 over x is 1 minus 1. So it's just the natural log of x. Over, let's see, we will have here the natural log of x plus, well, when I multiply this together, let's see, I'll get an x times 1 over x is 1 minus a 1 over x. So let's see, so what's going to be happening here is I'm going to have, again, a, excuse me, well, I'm going to have, again, as x goes to 1, I'll have a natural log goes to 0, natural log here goes to 0. This is going to be 1 minus 1, right? So that's going to go to, that's going to also go to 0. All right, so I could apply L'Hopital's rule again because it's going to 0 over 0 indeterminate form. I don't know whether it's faster to copy and paste or to rewrite this. So we have 0 over 0, so we'll apply L'Hopital's rule again. And if we do that, we'll have then the limit as x approaches 1 from the right of 1 over x in the numerator. And in the denominator, we'll have 1 over x plus 0, and then we'll have, this is negative x to the negative first, so we'll have positive x to the negative second. That'd be 1 over x squared. And now as x approaches 1, the numerator goes to 1, the denominator goes to 1 plus 1, which is 2, so the limit is 1/2. Notice in this situation, we converted it to a form that we could use L'Hopital's rule on by getting a common denominator and combining those fractions. Let's take a look at one more. This one, there have been times when I got stuck in a math class looking at this, and here's how we'll deal with this. All right, but it's, if you haven't thought about this for a while, or it takes you a moment to think of what to do here because it's a little tricky. Notice we have, as x goes to infinity, x is going to positive infinity, and as x goes to positive infinity, x plus 1 does too, so the natural log is going to positive infinity. So we have an infinity minus infinity indeterminate form. But here's what I'm going to do. I'm going to rewrite it this way. I'm going to think of this x as the natural log of e to the x. They're the same thing. Remember, I could take the x out in front because it's an exponent, and then the natural log of e is 1. So I get x here, all right, minus the natural log of x plus 1. Okay? And so now let's see, what will we have here? All right, well, I have the difference of logarithms, so that'll be the log of the quotient. So I could rewrite this way. The limit as x approaches positive infinity of the natural log of e to the x over x plus 1. All right, and now because of the continuity of natural log, I can take the limit inside, and I'll have the natural log of the limit as x approaches positive infinity of e to the x over x plus 1. And this I could apply L'Hopital's rule to. Let me see, I'll paste it here again, but I have to change this as an infinity over infinity indeterminate form. And so I could apply L'Hopital's rule, take the derivative of the numerator and the derivative of the denominator. I'll have the natural log of the limit as x approaches positive infinity of e to the x over 1, which is just e to the x. All right, now let's use the continuity of limits again. All right, and we'll pull the limit back out of the natural log. So I'll have the limit as x approaches positive infinity of the natural log of e to the x, which is just x. X times the natural log of e, and this x times the natural log of e is just 1. So I have the limit as x approaches infinity of x. So this limit is positive infinity. So here's some examples of infinity minus infinity indeterminate forms for you.